All right, so we're going to take a look at a few review problems. I've had a few people ask me some questions about some of the problems, and so I'm going to make these to get you ready for your test. And the first question I had was on the first page, number 32, this word problem here. From 1988 to 1998, the value of $1 in $1998 can be modeled by this function, v equals 0.002 t squared minus 0.06t plus 1.37. So you have this quadratic that models the value of the dollar compared to a $1998. V is the value of the dollar, and t is the number of years since 1988. What was the value of $1 in 96 in terms of $1998? And so the value is v, the t is the time since 1988. So basically what happens when they're asking you the value of the dollar in 1996 right here is that you are being asked to essentially plug that in for the time and find what the value of the dollar is. You do have to be careful because it is t, the time, is the number of years since 1988. So when you go to your calculator and you're plugging in for t right here and right here, you're going to plug in not 1996, but you're going to actually plug in 8 because 1996 is 8 years after 1988. So we're going to go to our calculator here and we're going to plug that in. So if we pull up our calculator and we type in 0.00, wow, 2, good grief. You guys know me and my struggles with the calculator. So 0.002, and then we're going to plug in t squared. So we're going to plug in a parentheses here. Come on, calculator. We're going to plug in a parentheses here, and we're going to plug in 8 years since 1996 is 8 years after 1988. So 0.002, 8 squared. And then we have minus 0.06t. So we're going to go back to our calculator, minus, make sure you actually hit the minus button, 0.06. And then you're going to type in a parentheses and plug in your t again. So again, you're going to plug in 8 for t. Come on, calculator. And then you have plus 1.37. So plus 1.37. So you plug that in, you press enter, 1.018. So basically 1.02 if you round it. So essentially what that is saying, if our value is 1.02 when we round it there, that what we have is that the value of the dollar in 1996 compared to $1998 is 1.02. Essentially, that means it's worth a little bit more than the dollar in 1998. So basically, it's 102% or $1.02 is what it's actually worth compared to 1998. So in number 32 here, and even in part of number 24 and number 25 down here at the bottom, all you're really doing is using the function that is given to you and you're plugging in a number for t. So essentially, it's kind of like what we did when we made a table of values and we were trying to find y values by plugging in x values. Essentially the same idea. The next question that I had was on the following page, number 9. And again, I understand word problems are typically the ones that you guys want to ask about the most, and that's great. I don't mind helping you out with these. It says a rectangular box is 24 inches long, 12 inches wide, and 18 inches high. If each dimension is increased by x inches, write a polynomial function in standard form modeling the volume of the box. All right, so I'm going to pause the video and do a little bit of drawing here on a box, and then I'll start it back up here in a second. It won't take any time for you guys, though. So here, essentially, I have my box, 24 by 12 by 18, 24 inches long, 12 inches wide, and 18 inches high. If each dimension is increased by x inches. So what that means is we're going to take and we're going to add x to all three sides. What we're trying to do essentially is this will be an idea of if you're a company that is packaging some type of product, you need to add the same amount to each side because you want to add enough space to put in maybe some protection for some type of object. If it's like a computer and you're putting in, packaging peanuts or, the bubble wrap, and, you need to have a certain amount of space added extra. That would be adding the same amount to all three sides, all three dimensions, because what that would do is create a bubble, so to speak, around the object inside there where you could actually put bubble wrap. So remember, volume for a rectangular prism like that, which is what a rectangular box really is always length times width times height. So when it says write the polynomial function, what we're trying to do is take our length and our width and our height from this actual box where we added something to it and create the function with x's over here. So I am going to switch them around a little bit so it looks more similar to what we're used to in class when we were looking at this. So instead of 24 plus x for the length, I'm going to actually put in x plus 24. But you could do it if it's 24 plus x. It would not matter. I'm also going to do the same thing with our width, which is 12 plus x. I'm going to put x plus 12. And then our height, x plus 18. So again, you could leave it as 24 plus x, 12 plus x, and 18 plus x. It would not change how you multiply. It's just going to kind of look funky compared to what we normally do when we multiply in class. So then, all you have to do to get your polynomial for the volume is to multiply these two together, and then multiply the answer you get times the height, x plus 18. So we're going to go through this relatively quickly because this is multiplication, and I think you guys enjoy multiplication, so to speak. But x times x is going to be x squared. X times 12 is going to be 12x. 24 times x is 24x. And then we do 24 times 12. So we take out our handy-dandy calculator. 24 times 12, since most of us probably can't do 24 times 12 in our head, including Mr. Harrison early this morning when I'm making this video. And you get 288. So that is what is going to be my last little number over there. So 288 right here. Sorry about the space there. I'm just trying to fit everything in this little small area. So 12x plus 24x is 36x. And then we take that and we multiply that by the x plus 18. So then we just multiply again. X squared times x is x cubed. X squared times 18 is 18x squared. Then we multiply the 36x times x. That's 36x squared. 36x times 18. Again, that's going to require me to go to my calculator here and do 36 times 18. You do 36 times 18, it's kind of hard to see behind there, but that's 648. So that's going to be 648x. Then I do the 288. 288 times x is 288x. That's supposed to be a plus sign right there. 288 times 18. Again, I'm going to head over to my calculator. This time I'm going to go to a blank screen here so it makes it a little bit easier to see. So we're going to do 288 times 18. So we do 288 times 18. Press enter on the calculator, 5,184. Beautiful number, right? So 5,184 will be what is over here. So then, all you have to do to get your final polynomial here is collect your like terms together. So your final volume would be x cubed, 18x squared, and 36x squared is going to be 54x squared. That's just adding 18 and 36. Then you have 648x and 288x. And let's see, that's going to be 800, 920, 936x. And you guys might need to check my work on the calculator. I'm going to save some time there. But 5,184 is the last number. This formula represents the volume of the box. So in terms of x, how much I add, this is what it's going to do to the volume. Now what I could do at this point is if I add 1 to all of them, I could plug in 1 here, 1 here, 1 here. It tells me exactly what volume my box would now be able to hold. And so then I can make determinations as a business whether I would be able to fit whatever product I'm trying to fit in there and how much bubble wrap I need to buy to fill in the space around it, things like that. Because then you could figure out how big the product is and subtract the volume of the product from the volume of the box and figure out a formula for exactly how much bubble wrap you need. So there's a lot of different things you could take this and go with that from there. But the only thing this one asked me to do is write the polynomial. You didn't have to solve it. All you had to do was write it. What you would have to do if you were solving it is you would have to have a number for the volume. You would need to know exactly what volume to plug in right here, and then you'd subtract it over to get it equal to 0, and you do your factoring. So let's take a look at the next one. The next question I had was on number 31, which is also talking about a box. It says a box is to be mailed. The volume in cubic inches of the box can be expressed as the product of its 3 dimensions. Here's the volume. So it's basically the same thing that we just did. This is the formula that was obtained from multiplying the 3 volume, length times width times height. It says the length is x minus 8. So you are given here what the length is. Find linear expressions for the other dimensions. Assume that the width is greater than the height. So if this is the length and this is the whole volume, if I want to find the other dimensions, if I know what the length is, I can divide the length, and that would tell me volume divided by length would be width times height. This will be the other dimensions. So essentially what I'm doing is I am dividing. The good news is, because I'm dividing this ugly polynomial by x minus 8, the volume divided by the length right here is one that we can use synthetic division for. So it's actually going to be pretty nice for us. Across the top, we're going to put 1, negative 16, 79, and negative 120. On the outside, because we're dividing by x minus 8, remember to do the opposite of that and put 8. Bring down the 1, and we multiply and add, multiply and add. So what is 8 times 1? That's 8. Negative 16 plus 8 is negative 8. 8 times negative 8 would be negative 64. 79 and negative 64 is going to give me 15. 8 times 15 is going to give me 120. Guys, we should expect that to be 0, even though we didn't know that x minus 8 is a factor. We do know it is the length. So we do know that it should divide evenly into this polynomial, which is length times width times height, because it is the length. What it means, just like what we did with factoring over this chapter, is that this volume, x cubed minus 16x squared plus 79x minus 120, that volume is equal to x minus 8, which is what we just divided by, times the answer that I get down here, x squared minus 8x plus 15. Remember, that comes from that division. If you don't remember how to do division, you may need to go back and watch the other video that I have on synthetic division. But this right here is x minus 8, the length, times this, which is actually the width and the height together. And so the problem is asking us to find what are those factors for the width and the height. So that's what we're trying to do when we find out what this one factors into. So this just goes back to our old skills before Christmas break, factoring a quadratic. X squared is going to be x times x. We split it apart, remember. Plus 15 tells me anytime the last number is positive here, I look in the middle at the negative 8. That tells me both of them have to be minus. A negative times a negative is a positive. And then the factors of 15 are 1 and 15 or 3 and 5. Which ones of those give me 8? The 3 and the 5. So this is the length, x minus 8. Which one of these would be the width and which one of these would be the height? Notice that it says assume that the width is greater than the height. Now, in real life, we can't assume that. We would probably venture to say that that's going to be the case most of the time if we're talking about a packaging box, but that's not always the case. So it says assume that the width is greater than the height. So which one is greater, x minus 3 or x minus 5? Which one would give you the bigger number if you plugged in an x? That would be right, the width and the height. Because when you look at this, x minus 3 would only subtract 3. X minus 5 would subtract 5, so that means it would be smaller. So there's your length, there's your width, there's your height. And that's just like what we had with that other problem we did with the box just a little while ago, except for we were working backwards this time and splitting it apart. All right, so the next question that I had was on the back side of the sheet on number 19. I'm actually going to take this one to a blank page here to make it a little bit easier for me to show you a couple of things with this. So let's go to a blank page, and it says find all the zeros of this function. Finding the zeros means you are trying to basically solve as if this equation was equal to 0. So you are trying to get x that would make this equal 0. And when I say x, I do mean x's, because if you're looking at this, this will be x cubed. You're expecting to get 3 different answers. Remember what that means is you could have all 3 of those be real answers, or you could have 2 imaginary answers and 1 real answer. Remember, imaginary answers always have to come in pairs. You also could have what we call irrational answers, where the answers are pretty ugly square roots, but they're still real numbers. So when we talk about the different types of answers, we'll look at another problem here in just a second that deals with that. We are looking at that degree to tell me what number of answers I'm going to have, but we're understanding that imaginary answers always come in pairs and irrational answers always come in pairs to think about what kind of answers those 3 answers could be. So there's actually 2 ways you could approach this. I'm going to show you the way that came to my mind first. When I first look at this problem, I see that I probably could try to do grouping. So it may work, it may not. We're going to find out. If I divide x squared out of the first 2, I get x minus 9. If I divide 27 out of these 2, I get x minus 1. Notice that this right here is not the same as this right here. That means grouping does not work. Does that mean I give up and I just go, oh, all right, well, I'm going to go to the next problem on the test? No, that's not what that means at all. That means if grouping doesn't work, I've got to try something different. Because if I'm supposed to find the zeros, I need to find what makes this function equal 0. So in class, we did this thing called finding the possible rational zeros. Remember, I told you I'm not going to get real panicky about whether the fact that you know these 3 words or not, whether you know possible rational zeros, or even if you write PRZ. I really do not panic over if you do that. What I want you to be able to do is realize that just like we did with factoring, when we were dealing with splitting up something like our box over here that we did just a minute ago, when we dealt with that, we used these x minus 8, x minus 3, x minus 5 factors of 120, because 8 times 3 times 5 is 120. And we use x times x times x is x cubed. The first number and the last number, or what we call the leading coefficient and the constant term, those are the 2 key things that I'm looking at when I'm trying to decide what possible numbers make it equal 0. So what we did in class was we took the last number, the constant term, and we factored it. 1 times 27 is 27. 3 times 9 is 27. Those are the only factors of 27. We also looked at the factors of the leading coefficient. The leading coefficient is 1x cubed, so 1 times 1. Remember, I told you in class that if Mr. Harrison gives you one with 1 in the front, you should be thankful, because that means all I have to do now is take all of these factors for the constant term and divide them by all of these. Or in other words, take all of these factors and divide them by 1. We do 1 divided by 1, 3 divided by 1, 9 divided by 1, 27 divided by 1. And just in case any of you are wondering what in the world am I doing there, I am literally dividing 27 by 1, and that is 27. Hopefully most of us can divide by 1, but just in case, I wanted to make sure you understood what I was doing. The next thing I told you to do is to put a plus or minus out in front of all 4 of those, because that takes care of any negative signs I may have. And it gives me 8 possible numbers, 4 positive versions, 4 negative versions of these numbers that might make this function equal 0. My next goal is to actually take out my calculator and I plug in these numbers until I find one that actually makes it equal 0. And this is exactly what we did just a few minutes ago in the video when we were looking at that first word problem where we plugged in a number in the calculator. And so we just try to see if we can find something that makes this equal 0. Be smart about which numbers of these you choose. Think about 27 cubed right here is probably not going to help me out. So just think about things like that when you go to start plugging in numbers. I'm going to save a little bit of time here. I'm going to go to my calculator. I'm going to pause the video and go to the calculator and do a little bit of work behind the scenes. And then I'll show you what makes it equal 0. So I came to my calculator and I was plugging in numbers into this function right here until I found one that makes it equal 0. So I'm plugging into the x cubed, the minus 9x squared, the plus 27x, and then the minus 27 that is here in the problem. I tried several different things, but then I got to 3, 3, 3. I plugged in 3 for x right here, right here, right here, and the calculator tells me that that is equal to 0. That's what I'm looking for. Now, also, you can kind of think ahead sometimes on this one. If you know how to kind of do a little bit of math with, 3 in your head, 1's probably not going to work and things. So it's okay to do math ahead of time and do things in your head. Just make sure that you're thinking properly through how numbers multiply together and how they add and subtract. But here's the point. If 3 is what I plugged in and I got 0 for the function, that means, and it has to be this way, x minus 3 is a factor of that function. That is based off of something called the Factor Theorem. I told you didn't have to know that theorem, but you do need to understand how this works. If 3 makes something 0, then x minus 3 would have to be a factor of this. In other words, what that means is x minus 3 should divide evenly into this polynomial. And guys, that is what we've done before Christmas break when we were solving quadratics and we set them equal to 0. So that means that this x minus 3 should be a factor of this. We need to find the other factor. So what we did, just like we did with our box a few minutes ago, is we use synthetic division. We divide this polynomial by x minus 3. Remember, this polynomial goes across the top row, the coefficients, and we divide by x minus 3 by putting a 3 here. Now, technically, you could also use long division if you want to. I'm not going to review long division here, but you could go back to my video and watch it if you need to. So we bring down the 1, and we multiply and add. So we do 3 times 1. Okay, so I'm not sure here where the video cut off, so I'm going to go back just a little bit here and kind of talk through this. I plugged in 3, and 3 was what made the function equal to 0. And what I mean by that is I literally plugged in 3 here, 3 here, and 3 here, and it made it equal 0. If 3 makes it equal 0, then we know that x minus 3 has to be a factor. That's by something called the factor theorem. It's also by the fact that we should remember from when we solved equations, if x minus 3 is a factor, then 3 would be the answer that you get when you set this equal to 0, using that zero product property. So basically what we have here is that anytime you know something that makes it equal 0, you know the opposite is a factor. But what that means when I go to find the other factor, just like we did with our box just a minute ago, is we have to use synthetic division and we divide by x minus 3. Now you could use long division, but you'll have to go back and watch that video on your own time. I'm not going to do long division here. So if I divide this polynomial by x minus 3, that means 3 is what I'm going to put here. Again, you have to understand 3 makes the function 0. That means x minus 3 is a factor. But if x minus 3 is a factor and we use synthetic division, we have to switch it back to 3. I know that's a lot of switching in your brain, but you have to know that that comes from those theorems we talked about. So then I use my synthetic division like we did earlier. 3 times 1 is 3. Negative 9 and 3 is negative 6. 3 times negative 6 is negative 18. 27 and negative 18 is 9. 3 times 9 is going to give me 27. Negative 27 and positive 27 is 0. Guys, we're expecting that remainder of 0 because we know x minus 3 is a factor. But this answer that I get, x squared minus 6x plus 9, remember that's what those numbers stand for with synthetic division. It would be the same thing if you did long division, it'd be on top of the house. That is my other factor. Because when we look at this, this times this would be my original polynomial. Because if you divide your polynomial by x minus 3, you get that. So that's how division works. If we take this now and we split this one up into x and x, plus 9 tells me to look in the middle, it would be minus and minus, just like we did a minute ago with our box. Factors of 9 that give me 6 would be 3 and 3. Notice that on this one, every single one of these is the same factor. That means if I were thinking about finding the zeros of the function, that if you set these things equal to 0, it'd be the same 3 equations to find my zeros. I would get 3 every single time. That means technically this problem only has one answer or one zero or one root of that function, and it's 3. That means it would touch the x-axis. If we were to graph this, it would only touch the x-axis one time at 3. So this is what we call a repeated root or a multiple root, or sometimes your textbook calls it a root that has a multiplicity of 3. So it would cause a little bit of confusion there because you're expecting to get 3 different answers, but you only get 1 because they're all 3 the same answer. So we've got one more problem that I was asked about, and we'll take a look at that one really quickly here. When I say really quickly, it looks kind of scary when you first look at it. Number 15 was the other problem that I was asked about. It says, for each equation, state the number of complex roots, the possible number of real roots, and the possible rational roots, or the possible rational zeros is another way to say that. Remember, we just talked about that. This one looks kind of complicated, but I'm not asking you to actually solve anything. I'm just asking you to talk about what kind of answers and how many there can be. When I say the number of complex roots, that means the number of answers, real or imaginary. So if you're looking at number 15, what's the degree? The degree of this function is 5. So that means there are 5 complex roots. In other words, there are 5 zeros or 5 answers that make this thing equal 0. So when it says complex roots, that's all it's asking basically, is how many answers, real answers and imaginary, because that's what complex numbers are. So there's 5 possible answers. The possible number of real answers, basically you have to think about real answers do not have to come in pairs, but imaginary numbers do. What that means is you could have 5 real answers, all 5 of them could be real, or you could have 3 real answers and 2 imaginary, or you could have 1 real answer and 4 imaginary, because imaginary answers have to come in pairs. So that's the only possibilities I could have. I could have 5 real answers, no imaginary, 3 real answers, 2 imaginary, or 1 real answer and 4 imaginary. So these are the possible number of real answers, 5, 3, and 1. And then the possible rational roots, or the possible rational zeros, is the thing that we did a minute ago. So we take the factors of 6, 1 times 6 and 2 times 3. We take the factors of 4, 1 times 4 and 2 times 2. And we divide all of these by all of these. So we take 1 divided by 1, 2 divided by 1, 3 divided by 1, 6 divided by 1. That's why it's nice when Mr. Harrison just gives you a leading coefficient of 1. But the problem is this one has a leading coefficient of 4. So you have to divide all of these by 2. 1 divided by 2, it's 1/2. 2 divided by 2, that's still 1. 3 divided by 2, that's 3/2. 6 divided by 2, that's 3. We already got that one. But then I have to divide all of them by 4. 1 divided by 4 is 1/4. 2 divided by 4, that's 1/2. We already got that one. 3 divided by 4, that's 3/4. 6 divided by 4, that's 3/2. So I did have some repeats in there, but I had to divide every single one of these constant factors by every single one of these, the leading coefficient factors. And now this one has more possibilities than that one that we did just a few minutes ago. But I did not ask you to actually find what the solutions were or to solve this. You were just talking about the different answers that you could have and finding the possible zeros. So I hope this little review helps on some of these problems. I know it turned into a 30-something minute video, but that's okay. It gives you a lot of little questions answered, hopefully, and you'll have some time to watch it and practice and get ready for your test. And I hope you take some time to do that. Take some time to study.